guys are going to think about what it takes to name a molecular compound. Yesterday was ionic, today molecular. Molecular compounds are those that are made up of only non-metals. So you'll see two non-metals in each of these. And like ionic, you're going to give each of these compounds two names, one corresponding to the first element you're given, another to the second element you're given. But unlike ionic, you're not going to see polyatomic ions, you're not going to see metals, only non-metals. So what you do is you give each of your elements a prefix, and the prefix tells you how many of that element in that particular compound, given a prefix. So some of these you should already be familiar with. 1 is mono, 2 di, 3 tri, 4 is tetra, kind of a weird one. 5 is penta, like a pentagon. 6, hexa. 7, hepta. Octa, nona, and deca. I think the weird ones in there are number 4, tetra. That's kind of a weird one to me. And then hepta and nona, kind of some weird ones too we don't see often. So each element you're given, you will give it a prefix to tell your reader how many of that element there are. The second element, just like in ionic, is given that weird IDE ending like sodium chloride. But in molecular, it would be like carbon dioxide, not carbon dioxygen, carbon dioxide. So same IDE ending like in ionic. Only one catch, only one, and that's that the prefix mono can be dropped if it's referring to the first element in the compound. So like CO2, carbon dioxide. There's no mono at the beginning of carbon dioxide, even though there's only one carbon. If it's first and there's only one of that element, you can drop the mono. So let's try a couple of those examples. SiO2, silicon and oxygen. If I put prefixes in front of each of those elements, I'd have monosilicon dioxide. But with that little catch, we can drop the mono as long as the mono is just at the beginning, the first element. We can drop the mono and just say silicon dioxide. So silicon, there's only one of those, must be, and dioxide, there are two. P and Cl, I've got phosphorus and chlorine. I would say monophosphorus pentachloride, but I can drop the mono since it's at the beginning and just say phosphorus pentachloride. You can check out the ending there, just like in ionic, it's not chlorine, it's chloride. It's a little name changer at the end. Here's a fun one, Se and Cl. Se is selenium, Cl is chlorine, or chloride, I should say. This one there's no mono, so we have to give two prefixes. 5, that's penta, so pentaselenium. And then 8, that's octa. Next one, N and S. N, that's nitrogen. S, that's sulfur. 2 nitrogens, so that's di, so dinitrogen. And then last one, monosulfide. So here you do have a mono, whereas here you could ignore it, because here the mono is referring to your second element. And again, just like in ionic, it's not sulfur, it's sulfide since it's last. One more, NO6. N is nitrogen, O, oxygen. Mononitrogen? Nope. Since it's first, you don't need a mono. 6, hexa, and O instead of oxygen becomes oxide. So mononitrogen hexoxide becomes nitrogen hexoxide. You also might see hexaoxide. Oftentimes though, if there are two vowels next to each other, you can combine them into just one. But tricky, these just take practice to get used to how they sound. If we go backwards, it's actually quite simple as long as you know your prefixes. You'll see a name like this and have to come up with the formula. You don't have to do crisscrosses or anything like that. You just write down what you hear. Carbon is just the letter C. Tetrachloride, well, chloride, that comes from chlorine, that's Cl. But you know how many in your prefix? Tetra, that's 4. So C, Cl4. Since you don't see a prefix in front of carbon, you can assume that it's one of those mono, where the mono is ignored. Next one, trinitrogen pentafluoride. I like these because you don't have to do charges or crisscross. You just write down what you hear. How many? 3. N3. Fluoride, how many F's? Penta, that's 5. So N3, F5. Really simple, actually. Hexaphosphorus, well, phosphorus is P. Hexa, ooh, how many is that? You gotta memorize these. 6, P6. And then heptaiodide, iodide, that's just the letter I. Hept, how many is that? 7. So P6, I7. No crisscross, no switch, nothing like that. Just writing down what you see. Dinitrogen octachloride. Nitrogen, that's N. How many? Di. That's 2, so N2. And then octachloride, chloride is Cl. Octa, that's 8. So N2, Cl8. Phosphorus monosulfide. Phosphorus, no prefix. You can assume that means it was mono, so just P. Monosulfide is just plain S, so P and an S. Now you'll notice that a couple of these, well, I guess just one, this N2Cl8, if this was ionic, you would have to work at reducing into a ratio that would be NCl4. But here in molecular, you don't have to do that. You're just writing down what you hear. You heard 2 nitrogens, you heard 8 chlorides, so that's what you write down. You don't have to reduce, you just write down what you see. So with molecular, trying to write out formulas, it's quite simple, no crisscross, no ions, you're just writing down what you see.